what we've got here is the heating system for the solar thermal collectors to heat the house up. And what it is, it's a fan assisted radiator, which also gets used on air source heat pumps, because they try and use a flow temperature that isn't always as high as your normal gas boiler type thing. So they make fan assisted, so you pull the heat out and spread it around more effectively than a normal radiator, which actually do work on convection, but you have to get them up to like 55 degrees, something like that.
Okay, so what we got here is the solar collectors, which is 3 sets of 15 tubes, go up to their manifolds. So we've got a total of 45 evacuated tubes up here on the roof, which if you looked at a normal system, would actually be called overpowered, as in it's too large for your expected domestic hot water use or central heating, that kind of stuff, because midsummer it would overheat. But fortunately, this situation is not a problem because we've got a drain back system. So basically, once we got to that kind of maximum desired temperature, the controller tells the pump to go off, and then a motorized valve goes on the inside by the pump station, and then the fluid that was being pumped up over the top drains back down and it stays empty, which is fine, because otherwise it would boil and make steam and put pressure and difficulties on the system. But this one is quite happy sat there doing nothing once it's got to what you required midsummer sort of thing. Well, that means we have got a large collector area, larger than normal, so in the winter we can get a good yield out of it, contributing towards our domestic hot water and heating the house up, which is the whole exciting thing about this project, is that we're trying to provide some central heating as well as domestic hot water by using quite a large array on our roof, which is going quite well. So let's look at the rest of it. Thank you.
So what we've got, particularly in the winter, is thermal solar collectors, my evacuated tubes. Don't necessarily get it that high, but they come round here, just around these pipes here, and heat the house up, which is very simple. It's basically just bolting this technology onto your normal solar thermal system, and it works very well. Thank you. Okay, here we've got a cupboard, like you have an air cupboard type thing. So what we've got, it's quite a small cylinder, I think it's about 90 litres. It's not a specialised solar cylinder, it's just a normal cylinder for heating systems. But that way we've got a smaller tank that will heat up quicker to the temperature you want it to have 10 showers, whatever, that kind of thing. And then it can go into the other system, which is controlled by these things. Here we've got a diverter valve that the controller will tell it we've got enough domestic hot water to send it around the other radiator to try and heat the house up. The tank, brilliant tank, stainless steel, came with its own expansion vessel, so that's all kept nice and safe. And the other thing is, domestic hot water, if it's not hot enough, still goes through a gas boiler if you need it to. So if you're not a qualified heating engineer, you're not allowed to touch a gas boiler, you know that. So there we go, gas boiler, which is currently off, don't need it, because I've got enough hot water, don't need to heat the house. But should I, what you can do is heat the tank up to, say, get halfway. If it's only 8 degrees outside, you can get the tank to 30 degrees, and then the boiler will get it up to 55 later on, but only direct drive when you're actually having a shower. It'll just do that 10 minutes of burst, and then you could be using the solar system to try and warm up the house as well. But basically, still got normal central heating if you want to turn that on and off. That could have been, the house could have got warmed up a bit by the solar, and then the central heating kicks in. You've still got hot water. Basically, if you don't want to have to think about it, turn the boiler on, gas boiler, and then you've always got hot water just because you want hot water. Whether it's economically preheated or not, you don't have to know about it. It just works, basically. But I'm quite enthusiastic, as you can tell, so I've got the boiler off as much as I can. We've got a thermostatic mixing valve, very important as well. So if the solar has heated the tank up to 90 degrees, you've got it set funny, and then it goes through the gas boiler as well, you're never going to get scalded, you know what I mean? It mixes with domestic cold water, so it's always perfectly safe, even if there's something malfunctioning. Very important. But there we go. Here we have another cupboard, which is actually containing the controls and everything. So the system's running right now. It's only a cloudy day, but it's doing quite well. So what we've got is, it's only 12 litres, but that's enough to drain down the whole system below the level of the solar collectors. This is a side gauge I've put. It's nice to see what's actually going on, because that tells me the level in this tank is at that level there. When it drains back, that will go up, and you can see it running. So that's lovely. So that's we've got the pump station pump going around, pressure gauges, emergency pressure relief. We've got a motorised valve that controls various things, and I've actually got a digital flow meter that records how much is flowing per hour type thing, the speed of flow, along with the temperature of that. And a controller calculates the temperature differential between that one and this one that's coming from the collector, and calculates how many kilowatt hours of energy in terms of heat we're actually doing, which is absolutely marvellous. So we've got the sensors coming down from the roof, all that kind of thing. So if it turns out you're interested and want to know a bit more in terms of the detail of the layout of the whole scheme, what I've got here is, in the back of this book, there's a diagram along with a brief description. It's not a complete manual. There's another one of the controller and the sensors and all that kind of stuff. Turns out it's in a book called Climate Malfunction by Gavin Cook, which is actually about the psychology of the planet. It's not about plumbing, but never mind. If you want the right things, it's in the back of that one. There you go. It's just stopped. See, it's drained back. It's got up to there because the temperature differential. It's removed the heat from the collector that it could, and then it'll start up again probably in about 10 minutes as that goes back up, because like I say, it's only a cloudy day, but it is doing well. Beautiful, isn't it? Thank you.